These are both 1/3 horsepower, just water pump motors that have been taken apart. 5-inch pulleys on them. They both run at 60 hertz. And this is the power cord going in. It's down into here. This will be the amps. If you can see it. Not really. 0.03, which is nothing with this shit meter. But what I'll do here is I'll run this alternator to start the motor. You can see here these wires here are all in series. The motors are in series when it's wired like this, but when I do this, you can see this is the 2 wires that go to the motor, putting them in series. But when I do this, it will cancel this motor out and put all the power to this one as if it's only running on one engine. So it has to spin all the mass with just one motor. But when I take the connection off again like this, these motors will be in series with, like, electrically and coupled together right here, the exact same drive. They both spin at 3450 RPMs at 60 hertz. This will be the load. It's pretty much all it has for one motor, or both of them. They're loaded down pretty good with spinning this alternator at 6900 RPMs. It's 2-to-1 gear ratio. But I'll have it hooked to this bulb. There's a bridge rectifier here. These are high voltage wires that aren't being used. But the bridge rectifier is hooked to, like, this stator in here has 14 coils on it, 14 poles, and so does the rotor. It's just a single phase stator now, but there's a center tap, so I got 7 poles on one side and 7 poles on the other side. So it just gives options to where I can hook the bridge rectifier because it's self-exciting. This is a resistor, just a saltwater resistor I'll use to control the field coils. So you can see the purple wires here go to the field coils, to the brushes. Here's the negative. I know we've got it hooked to the positive on this one now. Positive comes off the bridge. Bridge rectifier is hooked to 1/2 of the coils into seven windings on the stator. And the headlight, this light here, is hooked to the other 7. Let's see here and here. To start the coils up, I'll just short this out. It'll turn the alternator on, and then I can control the field coils like this. If I put it in further or take it out, it'll be hard to film with one hand, but try to do what I can. This is the amps here, there's nothing in it. As I start the motor, I'll try to keep camera on these amps. I'll do that now. 120 volts going in. Let's come apart right here. Moving them around. That's good enough. I put the motors in series. Sort this out. I'm pulling 6.6 on it. It's only pulling 2.5. That'll show how much power you really don't gain much. This is with the motors in series. It takes around 6 amps to make it bright and keep the power going. So now I'll put them only one motor. And it's running on one motor, it's pulling 6.5. You can see I'm still overpowering it quite easily. Not getting much extra power. But look how many amps they pull. It's taking 10 amps to make it run. 11, almost 12. Takes twice the amount of power to do the same work. Now they're in series, this motor's on again. It's only pulling 2.4 amps. It's under 6, 5.5. amps. I'll cancel this top motor out again. .7, 0.8. .8. 12 amps. Series again. 2.4. About 7 amps. Could just keep putting more of these in series, get more power. Cut each time you put another one in series, you cut your electrical input down. As one tries to pull more current, it makes the other motor work harder. Because it's getting more current.